Basically, to code this question, we have created a file selection.cpp in my VS Code folder. You can also create one in your VS Code folder. First, create a some folder like code or something, anything name, and then under that create a file selection.cpp, selections.cpp, or in any language you prefer. So basically, first we will be going to write the header of this uh, code. So basically it is hash include iostream. You can also use hash include bit slash stdc plus plus dot h. I generally prefer to use this one, include vector, but we will not be using vector. We can simply use an array. We don't need to use vector for this, using namespace std. So basically, we will be creating a void selection sort named folder, named function. So basically, what we will be doing is we will be passing int array uh, arr comma int n is the size of that array, and arr contains the array. So basically, int arr will be our array, and then int n is the size of that array. We are passing the size of the array along with the function. So basically, at first we will be taking an index 0 according to our explanation. What we took, that index 0 is going from 0 to n minus 1. I can again show you that one. So basically here the index 0 was index I. I was going from 0 to 0 to n minus 2. Okay. So I is going from 0, 1, 2 till n minus 2, and j is going from 0 to uh, n minus 1. Okay. So in the code also we'll be writing that only. Uh, from int I equals 0, I is less than n minus 2, I plus plus, and then we'll be taking a minimum integer during the position of that minimum element in each pass. Like in the first pass we were storing we were initializing the minimum at the first, like I equals 0th position, and then we are going to swap and find the smallest element and then swap with that. So basically initially we need to initiate a minimum index. So int minimum, we can write minimum equals I. We are initializing that to I. So now for int uh, goes from I to n minus 1. Okay, because each time we are initializing j from I, the first element is already stored, and then we are going to check with the next other elements. Like if I is at the first position, then we are going to check to the next elements. So basically j is initialized with I, and then j is less than equals to n minus 1, j plus plus. It goes till n minus 1, whereas I goes from 0 to n minus 2. Like the number of passes should be n minus 2, while the number of swaps should number of checks should be performed till n minus 1, till I to n minus 1. So we are going to check if arr, the array at the jth position, is lesser than the arr minimum. Okay, so if it is lesser than, then we will be setting the minimum to jth position. Now the ith position, like the initial which we are initializing, that is not the minimum element. So we are changing our minimum element location from I to j. So we will will like change from minimum location from I to j, minimum equals j, and then we need to swap that the first element with the current location of the minimum element. So To swap, we can normally use the swap library also, but here we are going to code it also. So we are creating a temporary variable, and that temporary variable is storing the location of the minimum, and then we are like swapping that setting that minimum to the a first one, and then first is set to the last one, the temp one. Okay, so equals arr I, and arr I is set to temp. Now normally we will write a main function what it need. We can provide the same example, same array as provided in the example. So int arr, we can initialize this, and then we can provide the same example: 14, 52, 34, 42, 22, and 8. Okay, so this is our array. Now we need to calculate the size of this array also. So int n is equals to uh, um, size of arr. Here we missed this one, this one. Okay, size of arr by uh, size of arr0. This is the method how we calculate the size of uh, our array. So basically we are going to call our selection sort function, selection sort. So selection sort, we are going to pass our array arr and the size of that array also. So arr comma n, and then we need to run a loop from 0 to the size of the arr to print the output. Okay, so basically this will be for int I equals 0 to I is less than n, I plus plus, and it will just this one, coutrr I, and then space is needed, and then we can simply return 0 because we are providing a int main. So now we are going to run this and check this. So okay, dot slash selection to print the output. So here we are getting the output as 8, 14, 22, 34, 42, and 52. So we can see the array is now sorted. So this is how the selection sort works, and uh, to make a quick recap of this, we can tell that selection sort basically searches the minimum element and then place it to the first position. Like we perform this till the size -1 times number of passes are performed, and here basically we can see in the code that we can see that this two for loops are being used, basically for int I equals 0 and for int j equals I. These two are the loops. So we can tell that the time complexity of our selection sort is big O of n square in the best case, worst case, and the average case also, because in each case if the array is sorted also, then also our selection sort like this check is performed the same big of n square times. So the time complexity is big of n square, whereas the space complexity is big of 1. Why? Because we are not because we are using a constant stack space, or we are not using any space here. We are not creating any element, any such element like that. So the space complexity is big O of 1, and the time complexity is big O of n square. Let me write in. Okay. So we can write that time complexity big O of n square, whereas space complexity big O of 1, because here we are using a constant space or no such space. Thank you for watching. Hope you liked the video, and also please give me suggestions what I should bring next to the table, what content should I bring, like some other sorting algorithms or the searching algorithms, or should I dive deeper into linked list, graphs or tree. Thank you for watching.